Hello everyone, and welcome back. So this time we're going over more forms of energy. So last time we learned that energy is the ability to do work. So work and energy, they're doing the same thing, just in opposite directions. You are giving up energy when you work. If somebody works on you, you gain energy. It's coming back to you. Okay, there's a lot of different forms of energy. The first we're going to get into is potential. Potential right here. Making sure my pen is actually working. So potential energy is mass times gravity times change in height, which I hope you will remember that mass times gravity is actually the weight. So this is weight times change in height. Force times distance. What was work? Work was force times distance. It was very, very similar. But potential energy is always about lifting something. And it's always based on how much you have changed the height. If you went from 7 feet to 7 feet to 10 feet, delta H is not 10 at the end. It is 3 because you went 10 minus 7. And I tried to use this with this little example right here. Imagine you're going to Earth, away from Earth. You're going from the Earth to the moon in an awesome little flying saucer. The numbers you use are not H2 or H1. They are delta H. That's what's going to tell you what your change in potential energy is, or your potential energy increase is. Okay? Remember that. If you just want to figure out what your potential energy is relative to the ground, well then H1 is 0, and so that'll just be H. But don't forget that delta H comes in handy. Okay, kinetic energy. Kinetic energy is all about movement, and this is one of the few that doesn't have that nice form where it looks like force times distance. I guess actually half of them don't. But kinetic energy is all about movement. If you have velocity, you have kinetic energy. You are moving. And you all know instinctively how this works. For example, if I kick a soccer ball, or let's just say somebody kicks a soccer ball at your face at 100 miles per hour, or other scenario, someone could kick your soccer ball at your face at 10 miles per hour, which would you choose? Hopefully neither, because that's just a bad idea. Why would you want somebody to kick a ball at your face? Okay, sorry, I had to set that up. But one of those is much scarier than the other. They have the same mass, but one is going much faster. When it comes to kinetic energy, it's velocity squared. So it goes up much faster as a function of velocity than its mass. But in a second vein, if you had a choice, or if you had two things coming at you, a feather and weight, both shot at your face, at the same velocity, I think I'd want to be hit by the feather. If I had to choose one or the other, feather. So you know that mass is also important there, and you will know this. You know this, you're like, this is okay, this makes sense. You know, obviously I get this, I'm a genius. Because you all are. You made it this far in the class. But that mass is also important. So both of those together, all that together, gives you kinetic energy. Okay, then thermal energy. So thermal energy, once again, we have mass. Once again, we have some strange things, Cp. Then we have a delta T, that's change in temperature. So what is the Cp? Well, that's a specific heat. It says, okay, if I put a bunch of energy into this, how much is the temperature going to change? And here's where you are all geniuses again. You don't realize this, but you're geniuses. When it comes to energy, everybody knows. Everybody understands it. You just don't realize you do. If you want to boil some water, and all you care about is getting the water to boil, you don't care about how much. Would you put a giant pot of water on the stove or a tiny pot of water on the stove? Which one's going to boil first? I'm guessing you're thinking, well, yeah, the small one. Why? Because the less mass I have, the more my energy can go to changing the temperature. Okay, so far so good. Second thing you might realize, which is scarier? Sticking your hand into lukewarm water or sticking your hand into extremely hot water? Answer, probably extremely hot water. You don't want to do that. Why? Because it's got a whole lot of energy and it's going to give that to you in the form of horrible burns. Oh my God. Other things that you know that you don't realize you're a genius. You know that if you had to choose between like walking barefoot over a concrete floor or walking barefoot over a carpeted floor, which would you choose? Probably carpeted, because that concrete floor gets really cold in the winter. I mean, it is just like it steals energy from your feet very quickly. Oh, one of those other things here. Even though the carpet and the concrete could be the exact same temperature, one has a lot more energy to take, or can absorb a whole lot more energy more quickly than the other. So all of this are things you know. You know how this works in real life. You just have to figure out how to translate it into a problem. So I know this is a lot here. We're going to do some example problems later. But until then, remember, you know energy. And if something seems weird, make sure you check it out. Okay, hope this helps you. And I'll see all of you next time. Bye-bye.